Good morning, dear all. A warm welcome to the second session of the Technical Forum. The first session was very inspiring. But before we will start, let me do an important remark. After the Q&As, you will get the opportunity for remarks. We prepared a survey to learn about your expectations and demands. The results will be a basis to improve and to develop the Technical Forum for you. Thank you in advance for supporting us. At present, we have an increasing number of participants. They are joining our stream, and I'm sure you don't want to hear more speeches, but you want to see the presentations, and so let us dive in now.
Ladies and gentlemen, dear friends and colleagues, dear World Money Fair Technical Forum supporters. A very warm welcome to the second virtual session of this 17th Technical Forum, and we are again very happy to welcome you all today.
Guten Morgen from Germany. It's 10 o'clock on sharply, and it's time for the Technical Forum virtual. The first session was very interesting. We had more than 400 registered people. 250 people actually were very active during the presentations, and a large part of those 250 were even more active in giving us and raising questions and being part of the Q&A. That is the right time for Dieter and myself to say thank you to you, and hoping and asking you to do the same this time. Enjoy the Technical Forum.
Yes, Thomas, and for this second technical session, more than 450 persons from 53 countries have registered. Among these are approximately 220 participants from international mints and national banks, 100 participants from international machine manufacturers and the industry, 20 participants from the international blank manufacturers and refineries. Remaining are participants from the so-called professional service companies and media. Well, today we have chosen 3 papers with again 4 presenters. The topics are blanking, coloring and minting.
After the 3 presentations have been carried out from ARTAZN, from Inorcoat, Teca-Print and the Royal Canadian Mint, again we have the Q&A to be used by yourself and to introduce yourself if possible. On the lower part of the website, you can raise your question, it will reach us, we will transfer that into the accepted area, and then you basically can communicate through us with the presenters.
Yeah, well, and introducing the first paper from ARTAZN, we have to look into the cost for the production of circulation coins, and the blank, in the respect of the cost, the blank has a share of approximately 60 to 70%. The optimum is that the blank material contains safety elements, and if it is perfectly mintable for a long die life, and considering the whole lifetime of a coin, which partly exceeds 15 to 20 years, maintains a clean surface quality also in the public perception.
The first presentation done by ARTAZN, located in the wonderful Greenville in Tennessee, is established as one of the manufacturers, leading manufacturers in producing coin blanks. We will see how brass-plated blanks will be manufactured and their advantages in the presentation from Vijal Agrawal. Vijal, stage is yours.
ARTAZN, a name that has been forged through innovation for over half a century, derived from the craftsmanship of which art is born and the heritage formed deep within melted zinc. With over 300 billion coins in circulation since our inception, continual product development is at the heart of what makes us a leader in the coining industry. One of those developments offers high security in both single piece and bimetal. This development is known as Zinc Secure.
We have copper, bronze, nickel, and bimetal options, but we still don't have a gold-colored brass, which is what customers are asking for. Vishal, can you come down to my office for a minute?
Hey, Mike.
Hi, Vishal. In looking at our current coin offering, we still don't have a good brass gold option. We need to do something about that.
Let me show you what we have been working on.
I will be talking about a new and improved brass plating process for zinc secure alloys that was developed here at ARTAZN. ARTAZN's current portfolio of plated zinc secure blanks include nickel, copper, and bronze finishes, but we know that customers have a great affinity for gold-like colors. Since brass provides that option, we undertook this study to develop a brass plating process on zinc secure. Our experimental approach for this project including the following steps. We investigated various bath chemistries. We then proceeded to measure the plating stresses on these chemistries. Once we analyzed the plating stress, we then chose the plating chemistry with the lowest plating stress and performed extensive design of experiments. We performed both screening and factorial design of experiments to optimize various process parameters. Once the process parameters were optimized, we then proceeded to measure product performance, and these included variables like coinability, tarnish resistance, color, adhesion to the substrate, and wear resistance. Once we got good values of product performance, we then proceeded to transfer the process to production to complete the project. We proceeded to measure the plating stresses on various bath chemistries that we studied. From our experience, we know that a lower plating stress bath produces better quality coin blanks. That leads to lower reject rates. So amongst the chemistries that we studied, we chose the one that had about 40% lower stress compared to that traditional process used on steel. Once we chose a bath with a low plating stress, we then proceeded to perform extensive design of experiments. The parameters were modeled and optimized using the commonly used JMP software. The parameters are listed here, and we then proceeded to get good product performance by optimizing these process parameters. We studied the product performance parameters keeping our customers in mind. One of the parameters that our customers want to see is coinability, which is a measure of edge quality. As you can see from the graph, the coinability numbers that we got were excellent over a range of compositions, and most of these numbers were above 90%. The next product performance criteria we studied is tarnish resistance. This property is especially important to our customers considering that it's a yellow finish. We performed extensive tarnish testing in steam, ammonia, and sulfur atmospheres. What we noticed was that the tarnish performance was similar to that of the traditional process used on steel. So in this case, there was no performance loss compared to the traditional process. We performed colored measurements using the standard LAB method. What we saw was the color was extremely consistent across a wide range of composition. And this can be an advantage for our customers in case they want the gold-like finish for a specific composition. Once we had excellent results on product performance, we proceeded to transition the process to production. For transition from new product development to production, we followed the IATF standard, which is used in the automotive industry. More specifically, at ARTAZN, we use IATF 16949 standard, and a schematic of the various steps that we take to transition the process to production are shown here. So now we have a new brass process that has the following advantages. It is cost effective as it does not require any subsequent annealing treatment like that needed on steel. It meets or exceeds the current performance criteria in terms of tarnish resistance, coinability, adhesion to the substrate, and wear resistance. Furthermore, this process is environmentally sustainable. Brass on zinc secure is completely recyclable. The coin blanks can be remelted in the furnace. And this process also uses lower concentration of chemicals, which is easy on waste treatment and also costs less. We also made bimetal coins with the new brass plating process. The cores of these bimetal coins were made of brass-plated zinc secure, and the rings were made of nickel-plated zinc secure. Some images of the cores and rings and of the bimetal coins are shown here. We performed separation force testing on various sets of zinc secure bimetal coins. These sets were made of combinations of different zinc secure alloys. The results of the separation force testing are shown in the graph. Also shown are the separation force values for several existing circulation coins and the typical minimum range of separation force seen in circulation coins. As you can see, the zinc secure bimetal coins performed very well compared to the existing circulation coins. There was also excellent groove filling in the core that reflects these high separation force numbers. For any coin material, providing security is important. So we performed EMS measurements on different zinc secure combinations. As you can see from the graph, zinc secure gave multiple unique signals that were distinct from each other as well as other circulation coins.
Mike, let me show you some of the samples that we have.
Wow. This is exactly what our customers are asking for. With the addition of brass, we now have completed the series for Zinc Secure, the most secure coin metal in the industry.
Thank you, Reader Thomas and the team for inviting us to the technical forum. As you can see, ARTAZN can now offer both single piece and bimetal coin blanks in different finishes, including brass. Zinc Secure offers better security, cost savings, performance, price, and supply stability, all with proven technologies. Thank you all for attending the presentation, and I look forward to answering any questions that you may have.
Dear Vijay, dear Mike Schubert, I am a little bit afraid about the content of this presentation, that it takes only one phone call to make things like this happen. Thank you very much for this excellent content and very nice presentation. I am sure there will be a number of questions during the Q&A. Dear audience, do not forget to raise the questions at any time. Vijay, Mike, thank you very much.
Well, in introducing the next presentation, we have to see that for many years, the color of circulation coins has been limited to the materials copper, nickel, and brass in different shades. Nowadays, much more colors is added both to circulation as well as to collector coins. Pad printing and the laser printing process have had an essential share in this. However, there is there a possibility of changing the basic color of the blank, and can both techniques maybe combined? These questions will be now answered by Roman and Daniel. We look very much forward to the presentation of the two experts.
Dear audience, welcome to our presentation. We are glad that we are part of the 17th Technical Forum. A big thank you to Dieter and Thomas for the organization.
Our topic today is nanotechnology meets pad printing. So we will start our presentation by introducing ourselves. My name is Roman Weidelich. I am CEO of Inorcoat. Inorcoat stands for Passion for PVD. We are a manufacturer of machine and magnetron devices.
My name is Daniel Fahl. I'm CEO of Teca-Print AG. And our home is the pad printing world.
So our topic today is, as mentioned before, nanotechnology meets pad printing. So what does it mean exactly? It means colors on coins. What do we know already in relation to colors on coin? On the one hand, we have, maybe some of you remember, we have presented in the last technical forum a presentation together with Axis in regards of rainbow colors via laser engraving. A second topic where we can see colors on coins is pad printing with Daniel today. And finally, decorative coating via PVD. This is a widely used technology and technique for a lot of different decorative applications within the architectural world, automotive world, etc. What are we aiming for? Why this topic? Our aim is to create unique coins, to combine known technologies, and to use benefits of the technologies to heal limitation in relation to the dedicated technologies which we know already. Our idea is to give designers possibilities to have additional variables to design unique coins and to produce easily and environmentally harmless ways to do so. 2-3 words about the respective companies. Inorcoat is based near of Stuttgart in Germany, in Ostfildern, and has a second site in Bulgaria in Plovdiv. It has been founded in 2019. We are a quite young company. Our focus is a production of plasma components, here especially magnetron cathodes and linear ion source and the derivates, and PVD equipments for various industries. Also, we are providing coating solutions, especially for the minting industry and for others, here for the coating on dies and also decorative coating solution on coins.
Yeah, now a few words about Teca-Print. Teca-Print was founded in 1973, so we have nearly 50 years of experience in pad printing. Teca-Print is based in Thaingen, which is very close to Schaffhausen. Furthermore, we have subsidiaries in Germany, Hungary, and France. And we are also a worldwide dealing company with agents all over the world.
Colors on coins. What do we know already? What you can see on this actual slide is 3 different pictures on colors on coins. The first one in the bottom is a pad printed coin. Then in the middle we have a coin which has been which has interference colors due to laser engraving of the dies, and finally the PVD coating. So 2-3 words about rainbow colors by laser engraving. Rainbow colors is a structure applied by laser on a striking die. This structure is transferred to the coin by striking. What is important here, and why is PVD also playing here a big role, is that when you are making such kind of design, you must be sure that you have a minimum lifetime of the die to be able to produce economically and in real condition an amount of coins. And this is why PVD coating is one of the technology which can be used, especially because it is replicating one by one the relief of the engraved design, which is very important.
Yeah, let's have a closer look on pad printing. In pad printing, you have various possibilities to design print images. You can print, for example, CMYK images, or you can also use RAL or Pantone colors, which are mixed according to a special recipe. Furthermore, you can also print nice special effects like glowing in the dark ink or ink with metallic sparkling effects. And also in pad printing, you achieve a very high resolution and a great edge sharpness of the images, which gives a very nice finish to the print image application. Furthermore, pad printing can be used with a single workstation, for example, or also with high-speed automations.
What is about PVD decorative coatings? PVD is a physical process, gives you endless possibilities in regards of creating new materials, especially if you have various cathodes installed in the machine, which give you the possibility to use various elements. It is already widely used in a lot of decorative applications. I'm just thinking about door handles, forks, knives, also in the watchmaking industry, on the medium price range watches. It is an environmental friendly technology because we have nearly no harmful substances which come out. It's always not for sure depending of the process which we are using. So we said to ourselves, why not to try this kind of decorative coatings on coins, and why not to try to combine different coloring techniques to really try to implement additional variables to make unique coins. So let's have a closer look on combining the technologies. Daniel will just take over and will explain you different aspects on that.
Yeah, so in pad printing, we know that we are very, very flexible in the print image design and also to print only onto specific areas, for example. But also you have some limitation in pad printing when you want to print onto sharp edges on deep engravings. And in this regard, we have looked for a technique which we can use to compensate this lack of technology. And with PVD coating, we have found a solution to create something new, colorful.
So we will have a closer look how is such kind of pad printing process happening. We have here a short video. Daniel will say some words to explain what we see now.
Yeah, so here we are seeing how we print color by color onto a coin. And yeah, so first color is white, and then we print further colors onto this coin with blue, green, and yellow images and letters. So this is you can say, a typical pad printing application.
The next slide is, what do we want with PVD decorative coatings? One of the major limitations which we can see today, especially if you want to produce PVD coated coins on an industrial scale, is that we have some limitation. One limitation is that we are coating the whole chamber, and this means also coating the whole coins with one or interference colors. However, this being a limitation, we have also some benefits, because the PVD coating is going to nearly all places where we want to have the coating, especially when we are speaking about 2D geometries or coin geometries. Why do I speak about the limitation in regards of only one interference colors? Because one of the problems nowadays is, if you want to make selective coatings, is that you have to apply a mask on the coin, which with known techniques nowadays is quite complicated to do complex masking on a low price, automated, in a way that we also have a lot of flexibility and can easily change the masking and easily change the design independence of the coins. In the next video, which I will show you, you see a normal PVD process. Here in this case it's a reactive process. in one of our standard machines, which we are offering for the minting industry. So here in this machine, you can, on the one hand, code coins, you can code dice, and you also have the possibility to code other tools like rimming tools and so on, every kind of tools which needs a solution to work on a longer lifetime. What is our aim? Our aim is, as I mentioned, a unique coin. It's combining technologies and to open new possibilities of making new type of coins. Daniel will tell us a little bit more about the possibilities via pad printing, but also about the combination of these two technologies, where we will show you later on a small film about it.
Yeah. So the great thing is that we have two existing technologies with a new application. So at the end, we create something new without a big investment if both equipments are already existing in the mint. And so this opens a new field for designing of coins and images. In the next video, we will see how we are printing onto a coated coin.
So here's the video. So Daniel, please explain us what is happening here.
So in this video, we see a coin which is coated in green color, and we are printing an image color by color onto this coin by pad printing. And also the ink adhesion is great onto a PVD coated surface. So it fits perfectly together, these two technologies.
So what is the outlook? What are we aiming for? What are we working on for the future? The idea is, you remember I mentioned the aspect of selective coating, selective decorative coating, but we have to think even furthermore. One of the last galvanic treatments we have in the industry actually is selective plating of gold and silver on gold and silver coins or other material. This is one of the last harmful processes, at least one of the last galvanic processes within this industry, also in the jewelry market or in other markets. So the outlook is that we are able to produce a mask which can be applied by pad printing, and which can sustain the specific ambient in such kind of PVD coating machines, which we can easily remove, so that we can really make great and nice coins, that we can make gold and silver plating, selective gold and silver plating, and replace finally one of the last galvanic treatment. This is one of our outlook which we are working on. Beside of this, we trust in the innovation of giving additional parameters and variables for designers to produce even more complex coins. And we are sure that this concept can be of interest for the industry, which we are looking for to develop a real PVD coated coin with a pad printing. Maybe Daniel, some last sentence on this?
Yeah, so we are really looking forward to a partner mint company, which can mint a coin, which we will PVD coat, and also we will add some pad printing to get something new. And we are really looking forward to see such a coin.
So, last sentence from my side. I want to again thank you, Dieter, thank you, Thomas, for giving us the opportunity to be on stage, even in a digital form. We value all the work you are both putting inside of this project, and we hope that quite soon we will be able to be part again on a real technical forum where we will meet each other and where we will be able to have a beer and to chat and to have nice discussions and nice evenings. Thank you very much. We are looking forward to the questions, and we are pleased to answer whatever it will be.
Yeah, thank you very much.
Roman, Daniel, thank you very much for this presentation and also for the special greetings about the beer and the networking. Yes, that part is missing. I think in the future we may look actually at a hybrid event where we definitely somehow continue the way we have started, but you are right, a beer should also be part of it. Roman and Daniel, you have given a very colorful outlook, a very interesting presentation. You are bringing fashion into the mint industry. Maybe it's also attracting younger people. So we hope that the Q&A will reflect what you two guys are doing well together. Thank you very much for that interesting presentation.
Yes, and after blank production and coloring, we are happy to have Shenyao Li on the virtual stage with the headline Reinventing Possible, the Next Generation for Circulation Coins. The MC4 for coin structure sounds like a four-wheel drive, but indeed Shenyao is talking about a multi-component composite circulation coin produced on a horizontal MRH 150 coining press. The innovation team of the Royal Canadian Mint in Winnipeg have accomplished some extra efforts in order to present a suspenseful paper on this 17th Technical Forum, and we can't wait to see it. Shenyao, the virtual stage is yours.
Good morning, colleagues. I'm very glad that we have this virtual meeting opportunity to share with you some of the recent innovations at the Royal Canadian Mint. The pandemic is still affecting all of us, but fortunately, this remote forum helps us to continue exchanging ideas. We can reinvent possible for us to connect as we're doing now. Thanks to you all for making the time and effort to make this happen. Reinventing possible is what I would like to talk about today, which is all about the Royal Canadian Mint's next generation of circulation coin technology, Phase 2. Multi-component circulation coin was the topic we presented at the Technical Forum in 2019. You may recall that it was based on tri-metal coin structure, consisting of one common ring, but two cores or two inserts that are stacked together. This tri-metal coin structure is referred to as multi-component circulation coins, or MC3 coin. Some of you may have seen the tri-metal test token sets that were sold out in 2019. The tokens were struck at 400 coins per minute using an MRV 300 high-speed press. We were happy that the tri-metal coin won the International Association of Currency Affairs Excellence in Currency Award for Best New Coin Product in 2019. The MC3 coin is able to give us some new features, not only more visual effects, but also a variety of material combinations for advanced covert security features. By carefully selecting materials, substrate, and plating, as well as their thickness, as shown in this schematic illustration. Built upon the tri-metal structure, we have now further advanced this multi-component coin by adding a fourth component to the coin structure. The fourth component acts like a separator, which separates the ring and the two inserts. As shown here, this new addition leads to a quad-component coin structure, or MC4 coin. The fourth component can be made from a wide variety of materials. They can be metallic, non-metallic, composite, solid, or plated materials, or any other special materials. Here you can see the struck tokens and the cross-section of the MC4 coin structures as some examples. More variations of the separators can be formed. Not only can this MC4 coin give more and impressive visual features, but also able to generate differentiated material-related properties, such as the electromagnetic signature and other enhanced security features. This slide shows more variations of the separators, which allow us to come up with various combinations of the coin structures. This produces enhanced visual and optical effects, visible or hidden security features. Let us use the top group as an example. Here is a ring. One core is in a normal round shape, and another core has the center hole. The separator has the post in the center location, corresponding to the center hole of the second core. By assembling and striking them together, the coin will show that one side looks like a tricolor or tri-component, while the other side shows the quad-component and the four colors. Depending upon materials selected, even more special features can be achieved. Now you may ask, how can you put them together in an effective and efficient way so that the coins can be produced at a high speed? This was the real challenge. How did we assemble and strike the four components together to produce the finished coins at high speed, say a minimum 300 coins per minute? Our team took on this challenge, not because it is easy, but it is difficult. We needed to find an effective way to fit the four components into a mechanism whereby the four will be placed and locked together for striking at the existing high-speed coating press. Here is what we have invented, an automatic assembly system. It looks simple, but novel and effective to first assemble the separator with one of the inserts by a wedge and angled sliding path. Now let me show you two animations so you can get a better idea how the assembly mechanism works. As you can see through feeding channels, the separator and insert are placed in the assembly unit. Both will travel along angled surfaces and paths before the insert is pushed into the separator. In the same manner, a cascade feeding and assembly is arranged for subsequent components. The innovative assembly has the following features: gravity-driven feeding, assembly along assembly distance, multiple merging forces in certain angles. The overall unit is a modular concept for flexibility. Eventually, we managed to process at 350 coins per minute by integrating the assembly into a Schooner horizontal high-speed press. This is indeed how the team has reinvented the possible. This new innovation has laid a great foundation to produce future high-denomination coins with considerations of material selection for cost effectiveness, production volume, advanced security features, and different visual effects for future coins. Thank you.
Shenyao, you seem to have dedicated your life to anything multi-layer plating, multi-component composite coin. I still have to look at a piece of paper when I say this because it's such an attractive name. Congratulations to such a wonderful innovation into the future, done by yourself, of course, and your team. Very nice of you to close the presentation actually with a successful team having developed that kind of technology. Dieter?
Yeah, and after the three presentations, we now look forward to the questions in the following Q&A session. If not already done, you, dear auditors, now have the possibility to pose your questions via the chat function. Also, in this second session, the presenters are not personally in the studio with us, but they will be happy to answer your questions in the live introduction, which we will now start. And here they are. Hi, welcome, Shenyao, Vishal, Roman, and Daniel. Good
Hello,
to see you.
Good to see you.
Good morning.
For some of you, early in the morning.
Actually, a wonderful arrangement. Thank you very much, Dieter, Thomas.
Very welcome. Very welcome.
Thank you. Vijay and Shenyao, I don't know what kind of drugs you took last night to get through that very short night, but you look fresh. Very welcome to this live Q&A. And Dieter, are we going to start with the first question?
Yeah, sure. The first one is for Alexander, from Alexander, who has a question for Teca-Print. Hi, Daniel. How many different colors can be applied with your system in one run?
Hi, Alexander. So thank you for your question. In pad printing with our solution, for example, we can print up to 7 colors per cycle. So this can be, for example, 7 RAL or Pantone colors. Or you could also print CMYK images. So this means by the color separation of cyan, magenta, yellow, and black, you can do something like a photo printing. And then it's even more than 7 colors, depending on the artwork design. Yeah. But the machine itself has up to 7 printing heads. This means you can mix 7 colors.
Thank you, Daniel. Thomas?
Well, the next one goes to Vijay. And Vijay, I've pre-read the question, and it seems like somebody's trying to sell you something. Listen to the question. How about your in-house nickel brass BM joining capabilities? Are you having enough joining machines, or are you depending on a third-party supplier?
Again, it depends all on the capacity, but we do have enough capacity. I'm probably not disclosing what capacity we have, but we do have enough joining capability.
Yeah, Vijay, I understand that as a translation. Don't shy to send in big orders. You will be able to handle them. Thank you for your answer, Vijay.
Well, giving Vishal a break, there are many questions for you, Vishal, but no, someone is it's popping up on top again because there's the like function on the questions, and the people who like the question can push these questions, of course, forward. Vishal, how about of bladed steel blanks is challenging? Why is your new brass bladed zinc material easier to handle or recycle?
I'm sorry, I didn't get the question, Dieter.
The recycling of bladed steel blanks is challenging. Why is your new brass bladed zinc material easier to handle and to recycle?
So when I talk about advantages of recycling, I'm talking about zinc here. So this process on Zinc Secure, we can just throw the brass plated zinc blanks into the furnace and reclaim full value. That it does not apply for zinc in that sense.
All right.
I hope I answered the question.
Thank you, Vijay, for putting that answer into the internet. The next one goes to Inorcoat. And for sure, this is Roman, as this is about PVD coating. Is your PVD process completely chrome-free?
Well, in regards of the coating of coins, we are using a titanium-based recipes and coatings. So we are not using any chromium. So due to this, we don't have any issue on hexavalent chromium or chrome 6. And in regardings of the coating of dies, for example, here we have also various approaches. So we have also titanium-based coating, for example, where we could see in the past very good results on die life. And in this case, it's the same. You also don't have any issue on hexavalent chromium or anything in this respect.
That was very clear, Roman. There was no chromium involved. This is what you said. Dieter?
Yeah.
For Shenyao, you showed an assembly mechanism simulation. The question is how to assemble these 2 components with the other 2 components at high speed. I guess some additional explanation might be helpful.
Sure, thank you, Dieter. This is a great question. As I mentioned during the presentation, the assembly line is a modular concept. The outcome of assembled first 2 pieces came from the first module. the assembled pieces would be going to second module as the one input in together with the third component in the second module. So basically, the second module would repeat what the first module did, as shown in the presentation. So this is kind of a modular, concept. So we have module 1 for 1 plus 2, and then move to the second module will be 1 plus 2 as the input, and then we have a third component. So basically 1 plus 2 and plus 3 would be in the second module, right? Did you get the concept? So, and then we can repeat this one and for multiple components. Basically, the beauty is that the modular concept takes advantage of the Schuler horizontal press, in which vertically we have a lot of space. Basically, the sky is the limit.
Thank you, Shenyao. Wonderful. The next. Are you asking
Shenyao, sky is the limit. I like that. That is an outlook which definitely sets you under pressure. And here's a question, Shenyao, also for you. This one, of course, we had to expect, because that's always coming up when there are new coins. So, Shenyao, this one for you. What is the durability of this M4 coin in circulation environment, such as push-out force, piece coming off from the coin, etc., etc.?
Thank you. This is a interesting question. I would say also is a challenging question. The geometry of the components in this coin structure are designed to produce that locking mechanism. Here, actually, we don't have to worry about the push-out force, because in general, actually, the four components coin structure, because of this coin, four component structure, the push-out force is actually stronger than bimetal coins. We are more concerned or considering the pulling force, how the pieces can be pulling out from the coin structure or in the bending situation. So the locking mechanism we designed into each component of the four components are in place to make sure the pulling force and also the bending conditions can make the component actually strong together to have enough service life in coin handling, especially in the coin processing process, including vending machines and sorting machines. So this is an excellent question. So, as I mentioned, that this is our phase 2 presentation. In our phase 3, we will provide you more information how those pieces are actually locking together. So, and we have something that you will like, and it's quite strong. Thank you.
Thank you very much. Of course, you would be prepared to answer this question. And raising from somebody this question, I think, really gives you the opportunity to answer it the way you did, describing really the locking mechanism a little bit. Dieter.
And I can also see if you're really interested now, you can contact us individually. And also, if you want, you can search our patent. So more details about the locking mechanism is in our patent.
Shenyao, don't give up too early. More questions will follow, but I give you a break. And for Brad Everton from Winnipeg, it's also very, very early morning. This is a question from Brad to Vishal. Has there been any die life assessments made on unannealed brass plating?
So we have not made any die life assessments, but we have done micro hardness measurements. We have seen the ductility and everything. And this brass is almost as ductile as we get on copper. And of course, we know that zinc is soft. So we don't expect any issues with die life measurements. But thanks for the question.
All right, that was a question from Brad.
Yes.
You have the next one?
The next one, Shenyao. Then the next two are for you, and I will combine them, because the next one from Steve Neer, you have already answered, because that was also about the locking mechanism, and you've referred also to the patent, which I think is a good idea to look into as well. Nevertheless, if you want to lose 2 words on this one, that's fine, but combined with the next question from Steve Gregory, well known from the Royal Mint in Lantrissant. Hello, Shenyao. Congratulations on your solution. It looks remarkable. Realistically, how long was the development process from pencil scratch to 200 pieces per minute? 250 pieces per minute.
Yeah, actually, the speed that we have achieved is 360 assembled pieces and assembled actually struck coins by using the Schuner high-speed press. So it's 360 coins per minute. So the development time is actually, you think about our phase 1, it was for the tri-metal coin structure. Now we're in phase 2 for this quad component coin structure. It takes quite some time, and it's a challenge project. But we have an excellent team. You can see Brad Everton now is get up so early to listen to all the presentations from different companies, the different technology. That's how our team has taken the challenge to do it. And so it's a challenge, but I think we're getting there. Thank you, Steve.
And
I hope I answered your question.
Yeah, just to add for Steve, of course, he knows that the 350 coins a minute is the starting speed of the high-speed press. Yeah, you cannot go lower for starting that. Giving you again a break, Shenyao, more questions will come for you. But for Roman, does the deposition of the colored coating performed on the blanks? If yes, can decoding occur during minting?
We make the coating after the striking process. So we are not, if I understand the question right, so we are, the coin has to be minted first, and after the minting, we can coat the coins with the color, for example, with a coating with a PVD layer. And after that, we go in the pad printing machine and are adding some additional colors if wanted and if necessary.
So to make this clear, you're not coating the blank, you're coating the minted coin.
Exactly.
All right. Thank you.
Yeah, that's interesting to understand, Dieter. I also did not immediately get that. Very good comment. Thanks, Roman.
Yeah.
The next question is from Wolfgang Schumann. Well known, he's from Schula. He's in the developing and design department. Shenyao, this one goes to you. And of course, he wants to hear facts. How many MC4 coins have you already produced?
That's a good question, Wolfgang. So, of course, we are still in phase 2. We have, of course, done a lot of, tested tokens. We haven't really produced any coins. If any country is interested in this, quad coins, we'll be happy to sell to you. But right now, from coin point of view, we haven't produced any coins, but we have produced a couple of millions of tokens. Yeah. So if Germany is interested in this new coin structure, we'll be happy to produce something for you.
The selling show will start right after the technical forum. Maybe you're live on stage at that time as well.
We are happy to support Shenyao. And here is
get a vaccine and then come to Germany.
Yeah, that's a good idea. That's a good idea.
Great. Turbjörn is on stage, on the virtual stage as well. And Turbjörn, thanks for this question to Vishal. Do you have experience with milled coins? Do the plating open in the edge during striking? What about zinc evaporation from the edge?
If I can get some clarification on this question, he's talking about the rim profile issues.
I thought you have the question in front of you, but I can read it for you again. He did ask, do you have experience with milled coins? Do the plating open on the edge during striking? What about zinc evaporation from the edge?
No, we don't see any issues, and that's what the coinability measurements were. We do realize that the edges are one of the potential failure points, and that's why we basically focus most of our measurements at the edges. So no, we don't see any opening at the edges, and then there is no question of zinc evaporating, but that's a good point.
Thanks for that.
The next one, again to Xinyao. Xinyao, this also must be a technical person. The question is, what can you do with the coins after the end of coin life? In other words, are the retired coins recyclable?
Well, I think a short answer, I would say yes, it's recyclable. As I mentioned during the presentation, it's it's the coin structure that can use metallic materials and non-metallic materials, right? If the four components are metallic materials, the recycling process has no difference as compared to bimetal coins. But if you're going to use non-metallic material as one of the components or a couple of components in this coin structure, and it's not difficult to come up a way to separate the metallic components and the non-metallic components. And then we can recycle the metallic components separately and the non-metallic components separately because of their unique physical properties or compositional properties. So it's recyclable. I hope I answered this question.
Definitely very clearly, Xinyao. Thank you very much.
Roman, you have another 5 minutes for your presentation in answering the question from Poland. Szymek is online and is looking forward to hear from you. He said, I understand that your system is able to do coating on dies and tools, but also coins. If yes, what colors you can achieve and every type of material?
So principally, yes, it's correct. Our equipments are quite flexible and versatile. So you have the possibility to coat all kind of different products. So it means on the one hand, coins. On the other hand, you can coat tools, dies, or even other things. So there is a lot of flexibility. Also, you have to understand that we are combining, in accordance to our design flexibility, we can put 1, 2, 3, 4, 5, 6 cathodes, depending on what you want to do, which gives you a very broad range of elements, always independent of what you want to achieve. Regarding the colors which we can achieve on coins, in fact, you have the full color range of I don't remember the word. I'm sorry. You have a big variety of colors, yeah, from yellow, green, blue, red, whatever you want to do, because we are controlling it over the gas phase, over the oxides or the nitrogen which we are putting inside. So in regards of this, you have nearly indefinite possibilities. In regarding of your last question, regarding of materials, it's always depending about how the degassing range is of a material and also how sensible it is in relation to temperatures. And this is something which have to be tuned together with the customer to tune the process in accordance that we are in the temperature range we have to be able to make the material, or also to control the degassing. For example, if you are thinking of brass coins, if you would like to make a coating on brass coins, you would have issues with degassing out of the brass, and this is something which have to be controlled, but which we can achieve. It's not a big issue. I hope I answered more or less everything.
Well, if you took from your presentation the rainbow as a benchmark, then you have a number of options.
This was
then you have a number of
that
options.
I was missing. In fact, you have the whole rainbow range of colors which you can achieve.
Right. Thank you, Roman.
Xinyao, next one to you. Technical forum, technical question to you. When do the EMS characteristics of the blanks coins have been checked? At the inlet of the coining machine or at the outlet of the coining machine?
And can you repeat the question again,
yes.
Thomas?
It sounds like that there is somebody, as Simon Neer, who wants to know at what point you are going to measure the EMS characteristics of the coins or the blanks. And the question is, do you measure it at the inlet of the coining machine? Maybe it is meant wending machine, or at the outlet of the wending machine?
That's really an excellent questions. So, and of course, if you think about the current vending machine mechanism, right? So you have multi frequencies and multi locations. So not just look at the center. You look at the actually center. For example, if you're going to take a bimetal coin as example, so you have the sensors. They check the center, check also their out rings. For this quad component coins, we could take advantage of the multi-frequency, multi-location, and also possibly even multi-sided sensors. So if you look at depending what we want to check, we can check at the different level of the depth going from the surface to the center or the core material. We can also check the center or the ring, or you can purposely position to check even the center ring. So or the connections or junctions. So and if you think about the current vending machines, that's kind of possibilities. Of course, as the MDC technical committee projects, they also talk about new sensors, new vending machines, new vending or new acceptance mechanism. So as I answered the question previously, like sky's the limit. So from coin industry, we developed the new coins. From minting industry, we developed the new coin presses. From a vending industry, we also developed a new sensor and new acceptance mechanism. It could be detecting different method. It may not be just a metallic. Maybe we don't use the EMS. Maybe we use non-metallic related sensors to check materials. So again, sky's the limit. If we want to push things, we can push it from different fronts. But this is a very, very good question. Thank you. Whoever is asking question, excellent.
Thanks, Xinyao. Xinyao, the next question is not a real technical one. This gives you a little bit of break to answer on the technical side. Shimek is asking you and giving compliments to you, first of all. Great presentation and very impressive innovation. What is the cost of such complicated coin in comparison to traditional solution?
This is another excellent question, Simway, wonderful. Thank you. So this is a very good question. Before we talk about the cost of this quad component coins, I think we should first talk about the fact that the 4 component coins are not for no denomination, as I mentioned during the presentation. Rather, it is for high denomination. In particular, we think the purpose of the 4 component coins is to expand the coin banknote boundaries, to convert banknotes to future high denomination coins. Considering the life of the banknotes and the life of coins, the cost of 4 component coins is still favorable. So I hope this answer your question, my friend Samuel.
I'm sure, and if not, he knows how to reach you. Here's your mobile phone number. That's
Dieter, thank you. Dieter, the next question actually is not in the board and not collected there. It reached me by email and it goes to Vijay. Vijay, it's a combined question and it's asking, have you done testing on coinability advantages with brass-plated zinc? That's A. And the B part of it, are these new zinc secure brass-plated coins are out in the field yet?
So yes, we have done extensive coinability measurements. As I mentioned before, that's one of the key aspects that we look at. And I also want to emphasize here that with our new process, with the low stress and with the process parameter optimization, we have been able to get similar ductile properties as on copper. So the coinability numbers are quite high. As far as field is concerned, no, it's not reached out in field, though we have done extensive testing. Waiting for the customer on this one.
Okay, Vijay, that is an invitation to the countries around the world to talk to you directly and get things done soon.
Absolutely.
Dieter, next one.
We talked about the vending industry, we talked about vending sensors, and here they are. Thomas is asking a question for Shen Yao, and thanks for that, Thomas. It is a complex structure. How much EMS variability do you see?
That's a challenging question, and for sure, there's a new features, right? From EMS point of view, and there's that, you have more element you have, and the more possibility for the detecting you may have, and also the challenge you may have. So we need to work on this one, work with the vending industry to see how we can narrow down, and also look at what specific things we want to detect. We don't have to necessarily detect all the components in this coin structure. We may target specific things we want to do, and also another thing is the coin security, right? It's not just one particular element. We are actually looking for different security features in one coin. I'll give you one example. Currently, the $2 Canadian coins, we have different kinds of securities combined with this one. So EMS is one of them, for example, and we also have like basically you combine covert and overt security feature together. But from variation point of view, definitely once you open more components, you open some windows you need to really focus on. You need to working on. You need to focus on where you should be looking into. So and I hope when we come back technical forum, we're going to deliver the phase 3 reports. You will see more details from us. But this is a great question. This is also a challenging things. When you have a different materials used for the full components, you would have different things you need to work on to focus on. Thank you for this question. I think this is very interesting now.
Thanks, Shen Yao, and we might invite Thomas, of course, and the Vending Association to give us some updates on the coming technical forum on their sensor innovations.
Daniel, not too many questions for you, and I need to say that even not raising a question for you, it seems that people are well aware of your technology and are enjoying. You are combining that together with PVD coating. Maybe there are a few ones coming. We also have the afternoon session, so definitely don't fall asleep, stay with us. The next one goes to Shen Yao, and it's from Torbjørn Hansen. And Shen Yao, typically we don't talk about cost when it comes to machine and how much is it and. But I think this one is very well valued from Torbjørn, saying, what is the production cost of this new coin compared to a bicolor coin?
Compared to mechanical coins.
Yes.
Of course. First of all, Torbjørn, thank you very much. I hope the temperature at your home is. Kongsberg is getting much better. I know. We last few months we compared the temperature almost on a regular basis. So I hope it's warming up now. So this is a great question. As I mentioned when Samuel was asking about the cost of these coins, for sure, if we look at the cost, right? So this would be more expensive than single alloy coin and expensive than bimetal coins. However, as I mentioned, this is not for no denomination, and also not for the coins were already there. We talk about how we can push the coin boundary, get into the situation we convert the banknotes into coins. So from an environment point of view, I think the coins would be more recyclable than, and also life of the coins and banknotes are not really comparable. So I think we should push for more, conversion from banknotes to coins. So if you think about that one, the cost is still favorable, more expensive than the bimetal coins, but is still cheaper than banknotes if you consider all the life cycle of coins and banknotes.
Xinyao, thank you very much for explaining that. Of course, we all understand the more components, the more security you put in. It has to have a value, and it can't be a simple, easy throwaway coin. We are looking for the long lifetime. We are looking for attractiveness, and that people want to use this tool as a payment. Thank you, Xinyao.
And thank you. Probably we can also add there, to produce the full components coin, as we're showing in the presentation, right? Not only you need a high-speed press, for example, the horizontal press from Schuner, but you also need the automatic assembly lines. So you have to assemble the full components or multiple components at high speed. It's not a numismatic coin, so you can do one at a time. You need to high speed. So basically, you need the high speed press. You also need a high speed assembly line. So from capital cost point of view, you have additional cost. But if you want to get your coin more secure, there's some investment you need to put there. So, but I think for future consideration, I think it's something we will try to push the boundary.
Thanks, Xinyao.
Thank you.
Xinyao, you have true friends in Winnipeg. Brett is giving you a break because the next question is for Inorcoat and Teca-Print. For both of you, can you expand your explanation on the masking application temperatures for the gold plating, silver, etc.?
So, thank you for this question. I think this is one of the most interesting questions in relation to coating on coins, because the idea of this project is at the end of the day to develop a masking which can sustain the ambient in a PVD coating equipment with the target to somehow get rid of galvanic treatments in relation also to gold or silver plating. One of the problems nowadays is that it is very complicated to mask a coin in an economical way. So we can make masking by having steel masks and so on, but they are not so exact and so on. And the advantage, Daniel, correct me if I'm wrong, the advantage of the Teca-Print, of the PET printing, is that we can print a potential mask in a very detailed way. And this would give us the possibility, if we are able to put a mask with PET printing on a coin, and to be able especially to remove it, to recollect, for example, the gold that we would plate, to be able to get rid of an additional galvanic treatment in a production facility. And we expected to be able to present you more details on this forum, but we are not ready so far. We have to be honest on that. We have not finalized our research and development work, especially in getting rid of the masking. But we can see already quite interesting results. So principally, the idea is you have a coin. You print a mask similar like you are PET printing a color on a coin. You put the coin in the machine. You make silver plating or gold plating, or it could be even another metal. Then you remove the coin of the PVD machine. You remove the mask and you recollect the material which is on the mask. And then you have a selected plated coin at the end of the day, with an environmental friendly process.
Thanks, Roman.
Dieter, instead of raising the next question to Xinyao, I will act on a compliment, which is putting words like big hands to Dieter and Thomas. That's very nice of you to do. In reality, it is a big hand to all of us, because without the presenter, without the audience, this work is all nothing. So really, we take this as a compliment, but we are definitely distributing that out into everybody participating on this technical forum. Thanks for that comment, Mr. Anonymous.
The other question for Xinyao, and here is the topic of here for circulation coins, how are these metamaterial coins be recycled? So this goes a little bit further after the lifetime of the coin, which is of course for many years to come. Yeah.
When I answer the previous question regarding recycling, I think that this is a really a good question. I can see a lot of people are concerning how we can recycle the material, how we can do things to help the environment, to help get our life better. So, and definitely this is something that we have keep in our mind when we develop the coins. So as I mentioned earlier, if the 4 components are all metallic materials, so the recycle method or recycle ways would be no difference as compared to bimetal coins. Of course, you have to deal with 4 different materials if you use different materials. But if a non-metallic material is used as part of the 4 components, first of all, we have to come up with a way to separate the metallical components and the non-metallical components. So it's not difficult to do that. I'll give you an example. Let's say the separator is a wood. I'm using this example, right? So and you could use some kind of density difference to separate the wood and the metallics, and then you recycle them separately. So and it's recyclable, but definitely it's something we should be always looking into. And the short answer again is yes, the 4 components coin is recyclable. Thank you for this question.
Thanks, Shenyao.
Okay, I'm putting the next one to Roman. Roman, what is the thickness of PVD coating? What type of materials did you try? Did you try coat magnetic materials?
So the thickness of the coating varies a little bit. We are in a nano range, so it's between 1.2 till 1 micron. Depends what we want to do. It's always also a little bit depending how much time we have to make the coating, how is the relief of the coin, how deep are the reliefs, and so on. This is one point. The second point is, as I mentioned, the base material which we are using to make this coating is titanium. We are then adding some reactive gases to fine-tune the colors. In regards of coating magnetic materials, so it always depends a little bit of the magnetic, how magnetic they are, but principally we don't see any issues in coating magnetic materials. Yeah. And we can even think of using magnetic targets because we are able to fine-tune our cathodes in a way that they are also able to sputter magnetic materials.
Thank you, Roman. This question was raised by Tomasz Jagaliński. Tomasz, thank you very much for being part of it and for raising this question.
Brad Everton, again, Royal Canadian Mint in Winnipeg, is asking Vishal, is the new brass plating able to be burnished? As an example, he mentioned a Spalek burnisher, but this is just an example.
Yes, thanks for the question. And yes, there is no issues with burnishing this finish. Yeah.
Oh, Vishal, that's far too short. You could have explained all about the polishing. Dieter, can you raise that question again, please?
I don't want to sound biased, so
give him some break in the afternoon session then.
Vishal, I think we have been capable to doing some of the first tests, and let me confirm this. If the plating is carried out properly, if the conditions are all perfect, I shouldn't say burnishing is a no-brainer, but it should be easily to be carried out, and it should not be a cost on add to the whole manufacturing process.
Right. Thanks, Thomas.
You're welcome, Vishal. Thank you so much.
Do you want to ask the final question for Shenyao? I think this is
okay.
Oh, there's one more coming now from Italy, Italian Mint, yeah?
Okay, Shenyao, this one goes then to you. Have you tried already different material combinations? And if yes, which combinations? And that the super duper designer from Schuler again, Wolfgang Schumann.
Well, yes, we have tried different materials, and of course for the think about the 4 component structure we talked about earlier. So if we don't worry about the rain, we don't worry about the center course, we can use a different materials or same material as the bimetal coins, but just think about the separator, use a different, right? So in the presentation, the black one you have seen is actually a composite material, where we actually have composite components even within that separator. And we also tried, use a different brass alloy as the, the separator. So, and yes, we have tried different materials, metallic and non-metallic. So that black, composite material is not a metallic material. It's a composite material with different components inside.
Thank you, Shenyao.
Roman, it looks like the final prize for the last question to answer is going to you. Italian Mint, Paolo. Paolo is on the virtual stage and is asking, how do you hold the coins in the machine, on the edge, and how do you assure the complete coating all around the coins? This is for Roman.
So we need to change the picture. So we are holding the coin on the rim with 4 very small dents which are holding them, and the pins which are holding it, it's nearly not visible. You will not see on the coin any holes or whatever. And actually we are then having 3-axis rotations and are able then to coat 360 degree. For sure, the coating thickness is a little bit different on the rims, but it doesn't affect the optical aspect. And from this point of view, we don't have a big issue. Yeah.
Thank you, Roman, and thank you very much for all the questions which have been asked and for the interesting and diverse discussion. Dear Shenyao, Roman, Vishal, Daniel, we will all see you later in a few hours in the afternoon session. Thanks a lot. Have a break, and thanks for your time and your active participation. Thank you.
You guys have done a wonderful
Bye.
job.
See you later.
And
Take care. Stay safe and healthy until we meet in the afternoon.
See you later.
See you.
Bye.
Thank you.
See you later.
Which we will now start. So welcome Shenyao, welcome Roman, welcome Vishal, and welcome Daniel. And I feel that Thomas is ready with the first question. For whom?
Yes, I am, Dieter. The first one will go to Vishal after I've also had the chance to greet our friends. We've already met this morning. You all look still good after the break you had. And Vishal, we will start with the first question in your direction. What environmental benefits do you see in your process in comparison to the traditional one?
Sure. So, of course, one obvious advantage of this process, not environmental, but you can get gold-like color. And then as far as environmental is concerned, there are 2 aspects. One is specifically for zinc. Brass on zinc is fully recyclable. You can just remelt in the furnace and get 100% of the scrap value, which is not true for brass on steel or even nickel on zinc. And second aspect of this process, which is beneficial from environmental perspective, is it uses less chemicals than the traditional process on brass. So less chemicals means less waste treatment and then less cost, and as well as benefits in the environment. So those are the main benefits.
Thank you very much, Vijay. These are benefits. Using less chemicals, saving environment, I think is what many people are talking about these days. Thank you.
Daniel, ready for this one. How many different colors can be applied with your system in one run?
So in one run, you can print up to 7 colors. So this means the pad printing machine has 7 ink cups. So you can fill these ink cups, for example, with RAL or Pantone colors. Or also you can print, for example, CMYK images. So CMYK image means that you have 4 basic colors: cyan, magenta, yellow, and black. And by the registration of each color and also by controlling the amount of each color, you can create something like a photo print. It's the same effect like with an inkjet printer at home. So in many inkjet printers, you have also the 4 basic colors, cyan, magenta, yellow, and black. And by controlling the amount of the color, you can print something like a photo, which is very, very colorful and which shows more than the 4 basic colors at the end.
Thanks, Daniel.
Roman, next one for you. That's the obvious one, which you already had this morning. Is your PVD process completely chrome-free?
Well, yes, the process which we have done now for the coins is a titanium-based coating, so we have no chrome at all. Same in relation of the dyes, we have various solutions, so we can also apply coatings without chrome, so on base of titanium or other elements. And that's actually one of our benefits because we have a certain flexibility in accordance to the setup of our equipment, which consists of different cathodes, which give us a possibility to make complex matrix with different elements and giving us, due to this, a possibility to get rid of chrome and also of chrome 6 if you want to decode, for example.
Super. Roman, thank you very much for this clear answer.
Daniel, another one for you, and I feel that was part of the presentation which is drawing back now to you. Is any special equipment necessary to use a pad printing machine for masking of coins?
So for masking of coins, it's the same process like for printing a normal color onto a coin. So the only thing you need is the special ink which you need for masking, and that's it. So this is also the huge advantage that only a special ink is necessary.
Okay, thanks.
Thanks, Daniel. I need to add one question to that to you as well, Daniel. How do you remove the ink later on? Is that a specific process?
Yeah, so we are still working on this process. The goal is to use a standard thinner of the ink. So this is the thinner which we also use for pad printing ink to get the right viscosity for the printing process. And furthermore, we are also doing tests with laser equipment to remove the masking after the coating process. But as mentioned, this is in progress, this is in work. But we see also already some results which are looking very good. So later we have more news about this.
Super. Thanks, Daniel.
For Roman, the PVD coating, have you tried to prevent tarnishing of silver? The proof coin polished table, will it have the same shininess after PVD coating?
So yeah, we are working on this aspect. So in regards of our coatings, what is quite good is that we achieve to replicate the mirror effect of the coating. But for sure, this also depends a little bit of the quality of the dyes, of the surface roughness of the dye, and so on. But yes, I think that our coatings can give nice results in regarding of the mirroring effect, that we're not losing anything of the polishing after having applied the coating. But again, this also depends of steel materials, of process which we are using, because there's a variety of processes which we can use. And but this can be explained in a more deeper manner in a direct discussion.
Yeah, the direct discussion you should have then with Torbjörn.
No problem.
He is very interested in that topic.
I'm making a little bit of a jump and not following the questions in the row, just to give Roman and Daniel a little bit of a break. So there's a question to Vijay.
Thank you.
You can go for a coffee if you want, the two of you. No, stay there. Don't go away. More questions are coming. Vijay, what's the recyclability of the new blanks?
So as I just mentioned, brass on zinc secure is completely recyclable. I mean, in our furnaces, we can just put it back in the furnace, and with the alloying elements that we use, you can basically claim 100% of the value. So yes, fully recyclable.
That was a question from Patrick Gimme, and you are saying fully recyclable, so that's 100%.
Yes, brass on zinc. Yes.
Super. Thank you so much,
Yeah,
Vijay.
thanks for the question. Thank you.
And your break is over. Roman, Daniel, Patrick Gimme is giving both of you compliments for the presentation. Great presentation he is writing. To Roman, where are the limits on what materials the PVD coating can be applied?
Well, in fact, limits are normally in accordance to the characteristics of temperature. So how much temperature can a substrate sustain? How is the degassing rate? So it means do we have a high degassing out of a substrate, which can somehow make issues in regards of adhesion. So there are a lot of aspects which are quite important to analyze. For example, also when you are thinking of sintering materials, depending on the quality of the sintering and how it is done, you can have some things which are degassing out of the material and which can affect the coating. So there are a lot of parameters which are somehow having to be checked, and in accordance to this, the coating recipe or the coating itself must be tuned to get a good result. Or it can even happen that it fails. Yeah, it can even happen that some materials you cannot apply a coating, and in that case, it doesn't work. But globally, there's a lot of options and a lot of possibilities to tune on processes.
You look to the sky, but I heard in the morning session already that the skies are the limit. And we're coming back to Shenyao's questions at a later date. Yeah, I know.
Daniel, don't fall into a boring time. Next question is for you. How long is the cycle time to mask a coin by pad printing?
So normally for the most applications, one print cycle is enough. So this means that the cycle time supports 3 seconds. And this should be fine for the most applications.
Are you saying 3 seconds for one mask, or is it multiple masks?
Yes. So it's 3 seconds for one mask. So this means so you take the special ink from the printing plate, from the cliché, and then you transfer by the silicone pad this special masking ink onto the coin. And for the cycle, you need approx 3 seconds, and then you have one layer of masking ink onto the coin, and this should be enough for the most applications. Maybe depending on the engraving, sometimes a second cycle could be necessary, but this can be only checked when you have the coin in front of you.
Cool, thank you, Daniel.
Thank you.
Shenyao, the promises come true. Patrick, asking you the question, how can a 4-layer coin be dismantled and recycled?
Well, Patrick, that's a great question. The short answer is for sure, yes, the 4-component coin can also be recycled. They are recyclable. If you think about the coin structures I mentioned during the presentation, we can have completely metallic components for the 4 components. We can also have a mix between metallic components and the non-metallic components. If they are all metallic components, there's no difference for recycling between the 4-component structure or traditional bimetal structure. If you're going to have a non-metallic component in the coin structure, and it's also easy to come up with a way, first of all, to separate the non-metallic and the metallic components, and then you treat them separately using traditional method for non-metallic and the metallic. I can use example. Let's say we're going to use wood as the separator, right? So you can easily destroy the coin after the coin retired, not destroy now, but after retirement. So, and then you can use the density and differentiation method to separate the wood and the rest of the metallic components. and then you treat them separately. So again, this interesting question. Our answer is that yes, they are recyclable. Thank you, Patrick.
And a comment for Patrick from my side. It's easy to start with the Schuler rimming machine. Thomas, are you taking the next one?
Brett Everton from the Royal Canadian Mint. Brett, I know you are not drinking in the morning, so you also have set your mindset to no limits. So this is the question. Listen to this. To Daniel, Roman, Vishal and Shinyao, have you considered collaborating to make an MC4 coin with a PVD pad printing obverse and a brass-plated zinc reverse? Brett, have you been drinking?
Let's do it. After
why not?
Get together, why not?
Sounds interesting and challenging.
That's interesting. Excellent question. Yeah.
So you will have to benchmark if we have gray hairs when we come back.
Okay, Vishal, you provide brass plated zinc as the separator.
Yeah.
And Roman, give us the PVD dies.
Okay.
And we put a color by Daniel on one side of the coins. So now you have MC coins. We're going to use the Schuler press to strike the coins. And Thomas, you need to have your burnishing machine to burnish the blanks Vishal has provided.
For each material, we are happy to supply individual burnishing machines.
And all of a sudden, we are all in one boat. Huh?
Actually, 6 of us doing MC coins together.
Yeah. Brett, the comments like this are actually firing ideas for the future. So thank you very much for doing that, Brett. And have a great day, unless you raise another great question.
Roman, the next question is for you. What is the thickness of the PVD coating? What type of materials did you try?
So the thickness can vary. It depends a little bit also of the relief of the coin design. It can be between 0.2 to 1 micron, depending what you want to do. In regarding of materials, so actually we are doing a reactive process. So we can use as an element titanium and then use oxides or nitrides to change the color. Also, you have the full range of the rainbow. Alternative is also to mix some aluminium or to make some aluminium oxide coatings. So there are a lot of possibilities, in fact.
Thank you, Roman. The next one is also considering the future, so that this will not only be collectors' corner where these colors can go to, because the question is asking, how is the wear performance on colored coins? Have you done any testing?
No, we didn't. For the moment, with this process, we are focusing more on the collector markets. So we didn't check yet the wear, especially for an environment of a circulation coin. But globally, depending on the core material, I suppose that we can have a good adhesion. And it's something which has to be analyzed in the future, potentially.
Put that next to your plan of producing the selected mask or get that into operation. You look into the option of getting colored coin into circulation.
The future will show us. Yeah.
You are young enough, Roman. No problem. Thanks for the answer.
Shinyao, both of us need another 15 to 20 years lifetime for the next one. What can you do with the coins after the end of the coin life? In another word, are the retired coins recyclable?
Thank you, Dieter. This question is very similar to the question Patrick asked previously. The short answer, yes, it's recyclable. And, the 4 components, as I mentioned earlier, it can be metallic or can a mix between the metallic and the non-metallics. First of all, we would separate if we're going to go to treat or recycle the retired coins. First of all, we would separate the non-metallic and the metallic, and then we're going to treat the non-metallic materials and the metallic material separately per different physical properties or compositional properties. again, the answer is yes, recyclable after retirement of the coins from circulation.
Okay, thanks, Shenyao.
Shenyao, another one for you. Is any country using this product? Of course, this is an obvious question, and maybe is Canada going to have this wonderful technology and coin?
Well, Thomas, I think this is another, I'll say interesting and challenging question. I wish I could have answered, but decide which coin is going to go, and it's not up to the mint, it's up to the central bank or up to the government. As I mentioned during the presentation, this quad component coin is designed for future high denominations. If any country is decided to move from the banknote, no denomination banknote, but going to high denomination coins, definitely this is I would say like a future and interesting, most secure choices for their future coins. So far, I haven't seen any country has come to us, because this is the first time we actually disclose we have this for component coins. But of course, we have already made some tokens for testing. If SPALAC would like to have a corporate tokens, we're happy to produce for you. That's the first to start commercial products.
Yeah, Shenyao, the message is to all the countries around the world: get ready for higher denominations, and let's start look into the option of using this for a long time. Thank you, Shenyao.
Yes. Thank you.
Roman, Patrick is coming first. I thought it's a comment, but indeed there's a question mark behind that. To Roman, for instance, porous materials, question mark?
Mm-hmm. Well, porous materials, depends what you mean with porous materials. In fact, coatings are following at least PVD coatings are following one by one the relief of the surface. And if you have pores which are closed, then the coating will follow them. But for sure, if something is coming out of the pore during, for example, a plasma etching process or whatever, and contaminating the surface, then you can have for sure issues on adhesion. Yeah.
Thanks, Roman.
The next one is from JD Walker. JD, greetings from Germany. Nice that you are participating in the Q&A. Lovely. This question goes to Shenyao, and of course it's about vending machines. Have you carried out tests with MC4 coin on vending machines? And if so, what were the results?
That's a wonderful question. Before I answer the question specifically to the quad component, as I mentioned during the presentation, the quad component, the coin structure, is developed based on our tri-metal coin structure we talked about at the technical forum a couple of years ago. For the tri-metal coin structure, yes, we have done a lot of EMS testing in working with the vending association members, and get an understanding where and how we should detect the EMS, what kind of EMS signals would come up by using the traditional or existing vending machines. So, and we're quite happy with the learning we have jointly got with the vending industry. And back to the specific, quad component coins, we haven't done any EMS testing in working with vending industry yet. However, we have used the vending systems that we have in-house in Winnipeg. So we pretty much understood where we should be focused on and what we should be looking into. No matter we're going to use all mechanical components for the quad coin structure, or we're going to mix between mechanical and non-mechanical coins, we think that we should be able to see where we should be focused on and what kind of EMS that we should get it. On the other hand, as I mentioned, this is something for future coins, for future high denominations. we're happy to continue to work with the windy industry. And we like to see if we can jointly develop some, maybe even new future sensors, future way of measure coins by using traditional, let's say, eddy current based winding acceptance mechanism. So we'll say what kind of sensor we should have, what kind of frequency we should have, what the positions the sensor should be located. So we'll be happy to work with the wind industry. I think, again, this is a very, very interesting question. This is some question I think we would generate a lot of future works. Hopefully, maybe in next technical forum, we can report our phase 3, progress, and may including some of the results with windy industry together. Thank you for your question.
Thanks, Shenyao, for that explaining answer. Thank you so much.
If we would have the chance of Manfred Matzinger-Leopold joining this session, he immediately would start, I think, 5 or 6 different subcommittees in our MBC working group. I think something like that might happen when we meet again in May on the MBC technical committee meeting, or the virtual one. Shenyao, there's another question for you. What is the durability of these 4 component coin in circulation environments, such as push-out force, piece coming off from the coins, etc.? So this again reflecting, of course, push-out force, which we talked already in the morning, and the whole lifetime of the coin, yeah?
Sure, yeah. Yeah, thank you. This is a great question as well. And if you look at our coins, right, so it's the 4 components. And based on the push-out force we did on our tri-metal coins, and also what we did on this particular 4 component coins, we don't have a lot of concern about the push-out force. Actually, the push-out force is stronger because of the double, stuck inserts, and also the locking mechanism we put into the components. We during the development stage, actually, our consideration or our concern is more on the pulling force. The pulling force or bending situation, any pieces, particularly the insert that would be come out from the coin. So that's this, particular area we focused on, and I'm happy to see that the locking mechanism we have put into the geometry of the components have ensured that we would have good and strong force to hold the 4 pieces together. For detailed locking mechanism, I would suggest that you can go to check our patent. We have more details about our locking mechanism in that patent application. Thank you. This is a great question.
Yeah, and of course, for guidance, everyone can look in the quality guideline of for circulation coins, which we have given to all the national authorities and to the mint experts to check what is needed as a push-out force for circulation coins. Yes. Thanks, Shenyao.
Shenyao, another one for you. Very simple one. The separator within the sections can be in metal or in polymer plastic.
Well, as I mentioned, the separator can be all kinds of materials, right? Can be metallic material, can be non-metallic materials. So if you think about all the materials that are possible to make that shape, can be the separator. So when I answer a previous question about recycling, I used wood as example. If wood can be used for this coin, any material can be used for this separator.
Thank you, Shenyao.
Thank you.
Peter, you're taking the next one.
Yes, again for Shenyao. The Mr. or Mrs. Anonymous is asking, I assume MC4 is patented. How to cope then with central banks which are interested but not want to fall under patented or licensed technologies?
That's a very, very interesting question. I have heard about this similar questions in many other products or other companies who have had their own patent, either products or process. So I think this is quite easy. Even though it's patented, we can, depending on what kind of opportunities, we can share patent, we can license a patent, or you can even help others to develop a new process which could leverage the patent, could also share the patent, right? So I don't think that's the hurdle for people to use this. And if there's a demand, and then I'm sure there's a way we can work with the central banks or any customers who are interested.
Nice answer, Shenyao. And as you said in the morning session already, the sky is the limit. And I just reflect what happened with the euro coinage, where we had at that time also a patent situation for the bimetal coins, and we had, of course, patent owners for different processes. And what happened afterwards, we had a nice Eurocoin series with a mutual cooperation between all the mints, striking then the Eurocoins in their countries. And I feel with your answer, I think in communication within the minting industry, this topic could be easily settled.
Agree. Thank you, Peter.
Next question is to Vishal. Also quite simple. Are you using a diffusion step in your process, Vishal?
Yeah, no, Thomas. We basically wanted to not use an annealing process if we could, just because we believe that a single step electroplating process like that we used can give better color consistency, and that's what we saw here. So no, this is a single step electroplating with no post diffusion involved or annealing involved.
Super, thank you, Vishal.
Vishal, the other question here is, what is the advantage of brass on, oops, now it's...
Oh, sorry.
That was sorry.
Vishal, I know the question because I read it, and I have deleted it now to give Dieter some trouble, to see how he reacts when there is an emergency situation. What is the advantage of plated brass versus zinc? Sorry about that, Dieter.
Versus zinc, or of course other zinc of solid alloys, or perhaps also the advantage of steel or plated covered steel blanks. Yeah.
So basically, this provides a gold-like color that a lot of customers prefer, and compared to solid alloys like aluminum bronze, Nordic gold, or brass, brass on zinc secure would be a cheaper option, and of course it comes with the security that zinc secure offers. So basically these two main benefits in terms of cost and security and providing the desired color.
All right, perfect. Shenyao, you showed assembly mechanism simulation. The question here of Mr. or Mrs. Anonymous is how to assemble these two components with the other two components at high speed.
Thank you, Dieter. Thank you for these questions. As I answered similar questions in the morning, this assembly line for the quad component coin structure is based on a modular concept. So if you think about the four components we talk about, in order for us to put the four components together, we would need 3 modulars. So the presentation showed one modular in which 2 components are assembled by using the wedge method. So if I can use a number to assemble the 4 components, will be component 1, component 2, component 3, and 4. So the first module would assemble 1 and 2. So we get 1 plus 2. So the 1 plus 2 will act as the input for second modular. So you would have 1 plus 2 and 3, component 3 going to a second module. So now you have 1 plus 2 plus 3 comes out from the second module. And then the 1, 2, 3 would be an input for third module. So now you get the fourth component. So 1 plus 2, 3, and 4. join together and go into the high-speed press. The beauty here is that the modular concept takes advantage of the horizontal Schooner high-speed press. And the horizontal high-speed press has open space on the bottom, almost like an Olympic stadium. So you have blue sky on top, there's no roof. So you can stack all kinds of modules for multiple components. Here, we talk about 4 components, but if you're gonna have, let's say 10 components, you can use the same modular concept built on the horizontal Schooner press. So basically, just like Dieter mentioned earlier, sky is the limit. So for this one, there's no limit for us to put multiple components here. The beauty is that we take advantage of this horizontal Schooner high-speed press. I hope I make things clear how we put the 4 components together.
Yeah, sure. Shenyao, I'm really looking forward to a classroom training at the Royal Canadian Mint in Winnipeg. I feel you need a blackboard, and we need to have a presence meeting to talk in details about this innovation, and perhaps there is a chance for us to meet soon again, if possible, in Berlin. But thanks again for these detailed explanations.
The next one, I'm trying to not say that he is with the Royal Australian Mint, because he is not. It's Mint Matrix, that's his name. Pravir D, Australia. Thank you for joining, Pravir. Dr. Lee, thank you for the excellent presentation. After the MC4 coins, when can we expect MC5 coin?
My dear friend Pravir, so you're way ahead of us. You know, if I could use the previous answer as an example, you know, it's possible for us to have MC5 coins, right? So if, again, we try to take advantage of Dieter's, horizontal press, we can add another module, and we can, put the MC5 coins there. Thank you. That's excellent.
Thank you, Shenyao. Dieter, would you raise the next one?
Yeah, again for Shenyao, you have showed the assembly mechanism simulation. My question is how to assemble these 2 components with the other 2 components at high speed.
Well, this will be similar to, as I mentioned, that this is the modular concept, right? So, and the first module, the simulation showed in the presentation is for the first 2 components. So, and we just go this cascading mechanism. We can put the 4 components into the high-speed press, and based on what we have achieved, we're able to achieve 360 assembled pieces into the high-speed coating press.
Thanks, Shenyao.
Shenyao, it seems to be the last one. I think that's also a very interesting one. It's about cost. MC4 coins, what would be the typical cost level in US dollar per 1,000 pieces for this kind of coins on a basis of, say, 10 million pieces? So that sounds like the first order is coming in.
Minister of Finance of Canada, huh?
Yeah, interesting question. You know, when we talk about the cost, right? So we have to think about how we're going to think about the cost. Before I talk about the cost of this component coins, I think we should first talk about the fact the 4 component coins are not designed for no denominations. And also it's not designed to replace the bimetal coins. Rather, these component coins are designed to produce a future high denomination coins. Particularly, we're trying to see if we can expand the coin boundary into the banknotes. So we like to say this is the opportunity for central banks to consider to convert the banknotes into coins because of the durability of coins as compared to the durability of banknotes. So if you consider all things together, consider about the recycling together, considering about the environment impact, so the cost will be much easier to understand. If you're going to say use the US dollar to say how much US dollar per thousand. But if you think about this one and the cost for the quantum metal coins, which is much secure than any coins that we have seen so far, would be still unfavorable. I think this is a good opportunity for central banks or for any like to consider cost savings, consider the impact on environment, consider about durabilities. This is a good opportunity. So to answer this question, the cost, even though I won't be able to give you a specific dollar value, depending upon what kind of a material you're going to use in these four component coins. If you're going to put a gold as a separator, for sure, that cost will be much higher. But if you think about some composite material, you may be able to use, and then the cost is still favorable in terms of converting banknotes into coins.
Shenyao clearly understood this question was anonymous, but it is not known as you are well known in this industry. So I'm sure there is coming in an email very soon. Thank you very much, Shenyao.
Thank you.
Yes, dear friends and colleagues, ladies and gentlemen, thank you very much for all the questions and for an interesting and diverse discussion for this afternoon session. And dear Shenyao, dear Roman, dear Vishal, and dear Daniel, to all of you, congrats. And thanks a lot for joining us for such a long time and for these many questions. And you had a very early morning, and for some of you it's now also a late afternoon. Thanks a lot for joining us. Stay safe and stay healthy, and hope to see you soon again. Perhaps not in a virtual stage, looking forward to that as well, but on a personal meeting as soon as possible. Thanks again for all your efforts.
Thank you.
Bye-bye.
Thank you.
Take care.
Goodbye.
Well, these were entertaining and technically filled 60 minutes is what I wanted to say, but that's not true. It's closer to 80 minutes. So again, we had a very interesting Q&A with the participants from the outside audience. Thank you very much, audience. Thank you, participants, to make that Q&A so successful. This is also at this point the right time to thank the World Money Fair organization and Brainstorm to make this virtual transfer into your homes and working stations happy. Otherwise, we would have not met at all, which is also no solution.
Yes, dear friends and colleagues, and if you found these presentations interesting, you will certainly find them at a later date on the World Money Fair website. Registration, you have noticed that your friends and colleagues might not know, but please tell them the registration is free of charge, and registered persons can also watch the previous sessions at any time they want to. Stay true to us also in the session 3 and 4. We will meet again for session 3 on April 29th. We have prepared for you for the session 3, 4 presentations from the companies Mint of Poland, Gräbner Pressensysteme, Sacken Kieselbach, and Welek, and we're very much looking forward to this.
There's one comment to be made on the next session, which was originally planned to be in May. That's not happening. It's now June the 10th. Please change that into your calendars, and we also will give you a pre-warning with emails or any other way of communication so that you can be part of this session as well. If you like the session, please tell your colleagues, spread it out into the Mint industry, and let us have your feedback as well so that we can continue to improve what we have done so far also for the next times, which leads us into the comment that Barbara will also have a few comments soon. But for us?
Yes, for us it's time to say goodbye. Thanks a lot, and stay safe and healthy, and hope to see you soon again.
Time for a gin tonic. Bye.
Bye-bye.
Thank you, Dieter. Thank you, Thomas. Thank you for listening. And I'm sure you enjoyed this session too. Please support us by answering our survey. Your response to our questions will let us improve and develop the technical forum. And please save the date for the third session on Thursday, 29th of April. See you and goodbye. Stay healthy and see you soon. Bye. So.